Okay, so what we talked about last week was microcontrollers. And the whole purpose, what's the difference between a microprocessor and a microcontroller? I know it's been a week.
Is it one like the hardware and one's the software?
Kind of, but also kind of not. It's a good guess. You're getting there. A little bit more though. Anybody know what the difference is? Okay, so 2 weeks ago we talked about microprocessors. A microprocessor is the actual, like, computer component. It's the one that does all of the calculations. It's the one that routes all of the information. Every computer touts what size of processor it has. Processor for the Raspberry Pi is ultimately what makes it do what it does. So the microprocessor is the computer part of the actual design. It's the physical computer. It's the one that interfaces with the registers. It's the one that interfaces with memory systems, that sort of thing. The microcontroller takes a microprocessor and plugs it into a physical system where it has input-output ports, and its intended use is to control a process. So it's a computer that's constructed to control a process. So that's what we've been talking about the last few weeks. What we're going to be talking about this week is languages. Now, part of your reading assignment that was due today discusses the assembly language. Okay? Does anybody know what the assembly language is used for? Anybody done the reading assignment yet? Okay, well, the assembly language is actually what physically controls how memory moves in and out of registers. It controls how information is dealt with on the bit level. This is the most basic computer language. Okay, when it comes to assembly, what you have is you have your physical hardware and your processor. It's part of this. And your physical hardware communicates with the assembly language. It's how you actually control which gates turn on, which gates turn off. It actually interacts with a machine code specific to the physical hardware, but we're not going into that. That's a step deeper. Now, if you've done your reading assignment, the discussion on assembly and the entire chapter, quite frankly, is really gross. Assembly is not a language that a lot of people enjoy programming in, which is the whole reason why people created programs that will generate programs in assembly, if that makes any sense. So when assembly was created, it was here's how to distribute bits. It's a very, very fast language, okay? Because it is the lowest level language. It interacts directly with hardware. A clock cycle will very closely represent a command given in assembly, okay? Oftentimes, assembly language is a very long code. It takes a lot of code to do anything. It's still very fast, but you may have millions of lines to do a very simple process. Just because it's directing, pull information from this register, push information to this register, gather information from this memory source and put it into this register to prepare for a calculation, okay? So there's a lot of code involved in assembly. And for what people said is they looked at that and they said, well, this is a nightmare. We have to create a language that's going to handle assembly. And this is where they created the C language. Okay. C was created, well, actually it's the third in a series because there was an A language and a B language, neither of which were very successful. But C was a language that was created, and the whole goal is that C outputs commands in assembly, which then interact with the physical hardware. Now, C, by nature, is a slower language than assembly because it actually processes stuff that has to get put into assembly, and there's a little bit of a transition there. Okay? However, that said, it is still a fast language. It computes very quickly because it is still so close to what assembly is. I wouldn't say that C has a lot of code. C tends to be a lot more versatile. It has a lot of built-in functionalities. But it still has a good amount. You still have to define your variables. You still have to design, I believe that C involves fields. I'm still going to say it's lots of code because it is still a lot of code. Now from C, C is still a lot of code. It's fast, it computes fast, it processes very quickly, but unfortunately, it's still a pain in the butt. It's not as bad as assembly. And it certainly has a lot more capabilities of programming rather than taking 50 lines to do something. C compressed a lot of that into just one line. So one line of a C code may represent 50 lines in assembly, okay? Or 150, or 250, or 5,000. It's something where it very rapidly it shuts down this code. However, there's still a lot of code. When I said lots of code up here, I meant lots and lots of code. And here, this is just lots of code. Okay, C gave birth to a number of other programs, such as C++. I believe Java came out of C. There are other languages that were written in C that were now used to control the language in C. Okay? So now we're getting to a much higher level language. Now they're still relatively fast. But the idea here is that it's much faster to program. It takes fewer lines of code, and there's more functionality. You can derive more different functions in C++, than were present in C. So more functionality, fewer lines of code. And that's kind of the appeal of both C++ and Java. I believe Java transitioned the kind of programming that C used into more object-oriented programming, which some people prefer that, some people hate it. Personally, I hate Java. Okay, so now you see we're getting pretty far away from assembly. Well, Python was built in C++. And the beauty of Python is that Python is one of the slower languages that it has been created. If you'll notice, it is really far away from the physical hardware. It has to code something unless my mom's from California. It has to code something that goes into C++. That C++ language has to then convert something that goes into C. That C language then has to convert something that goes into assembly that ultimately goes to the physical hardware. So there's a lot of steps involved in this, which makes it one of the slower languages. Now, ironically, Python is one of the most used languages in today's world. Not to say that people still code in C. Very few people still code in assembly. Yeah.
So, when you mean it's slower, what do you mean by it's slower?
Okay. Make sure I'm not writing off the... When it comes to speed, okay, your clock operates at a very certain constant clocking frequency, right? Well, for each one of these clocking cycles, we'll try to make sure it's on the rising edge, you may have one piece of information from assembly language that gets processed. Okay, so this may be 01001, and that may represent an A in the assembly language. Okay, well, the problem is, in order to issue a code to the assembly language, it takes several words, not just a single letter. So while one letter may take, if this is a 2.5 gigahertz processor, this is 1 over 2.5 billion. So this would be 5 divided by 2.5 billion, which that is what? It's 2, I don't know, let me calculate it. In order for this program to accept the letter A, and if it only took 5 bits to do so rather than maybe 8 or 64, this would take 2 times 10 to the negative 9th seconds. Okay, 2 nanoseconds in assembly. Problem is, if you just simply write in 01001 in this, it has to compile every 0 and every 1, which means it takes a lot more than this to specify a letter A. Bless you. Because now you have to specify, is it a string? Is it a number? Is it a character? So what ends up happening is, in C, the letter A may be something like this. where now it's about 3 times as long, where one of them specifies the letter A and the rest of it specifies the formatting. Okay? Of what it is, what it means. Now 3 times as long means it takes 3 times as much time for this to happen. So which you may be looking at 6 times 10 to the negative 9th seconds, or more than likely it's actually in order of magnitude slower to read a single letter. Okay, in assembly, very fast. In C, I mean, this is still pretty fast. But then when you get down into C++, you lose an order of magnitude of speed, where it just takes longer to send a single letter A to the assembly language. And then when you get down to Python, Python cycles, I mean, the fastest speed that I've seen a Python program work at is in the megahertz level. You're losing 1,000 clocking cycles that are needed to perform a single operation. So it just takes more clocking cycles for this to break up its code into each individual one, where this breaks up the code that goes into C, that breaks up the code that goes into assembly, where assembly itself breaks up the code to communicate with the machine code on the physical hardware. So that's what I mean by slow. It takes longer to do this exact same operation coded in Python as per assembly. Does that make sense? Okay, any other questions on that? Okay, so there are still people who code in C. There's actually a substantial number of people who have to know C because a lot of base programs are written in C. And if you have a bug, well, you have to go back to your base program. But a good question for you is, if this is so friggin' slow, why is this one of the most widely used languages right now? It's very simple. Python is well established as the easiest language to learn. It's very simple. Code there doesn't require a whole lot of development to do. But I mean, you have a very easy language to work with, but it doesn't have any near the functionality, the power, the speed of a lot of these programs. You can write an application in C++ that does image processing in real time. Image processing is one of the more, it's one of the more memory intensive operations that a computer does. But you can write that in real time in C++. Writing that same program in Python doesn't really work. In fact, you may be able to process a single image every minute rather than every 30 frames a second that C++ can handle. So why is this so much more popular? Why is this being used? And one thing that Python is used extensively for is something called machine learning. Anybody know what machine learning is? Yeah, this is used for development of AI. Most AI programs that we have are written in Python. Why?
Easier for us to understand.
Well, it's easier for us to understand, yeah. But I mean, don't we care about speed? Don't we care about functionality? Don't we want machine learning processes to be very quick? Why Python? Huh?
Something simple, but you can make it more complicated later on.
What did you say? Time? It ends up, well, it takes less time to program it here because this code is much simpler, it's easy. So if that's the case, yes, okay, if you are the best person in the world at C++, it's still going to take you less time to code it in Python. The code is going to be simpler, as you said, Grace. Okay? This is just easy. The whole reason why we use Python is because it's easy. In reality, though, Python is I've heard it called as a wrapper for C++. The functions that Python does execute C++ commands. A lot of the machine learning algorithms are written in C++. But the actual access for them is in Python. And so what Python does is you execute a machine learning command in Python, it then goes to C++, does a number of operations, and then interacts with the Python code to get it out. So even though a lot of the AI systems are written for Python, they're written in C++ and sometimes even C. And it just goes up the chain of command. So that what Python does, and what Python does very well, is a number of its libraries are written in the faster languages. And in order to execute much faster than it does, it just goes into here where it'll open up a C++ shell, run a program for a very short amount of time, close the C++ shell, and then push that to Python. This is a very unique language in that it continuously jumps up here, runs a small amount, and then pushes down here. Rather than sending the entire code up through the chain, it stops here, comes back here, and then goes through the chain. So the appeals of Python are that they're easy. It has AI capabilities, which are written because it's fast to code. Python reduced a lot of the redundancies that are present in other systems. You may have two functions that do identical features, but one function runs slightly faster than the other, depending on the application. That is a problem that happens in all of these because there's multiple ways of sending information to a register and pulling information out of that register. So you may have one command written in C that does it one way, and you may have another command written in C that does it another way. And one command may be faster, depending on the application. One command may be slower. It has no way of knowing. What Python does, and what actually makes Python slower, in part, is Python says we should only have one command. It should only do it one way. Which makes the back-end Python actually much simpler to operate. It makes Python a very memory, not a very high memory program. It's actually there's not very much memory associated with it. Whereas these will have thousands of libraries. Python, you actually have to bring in the libraries, and bringing in a library does slow down Python. Okay, so this is just a basic overview of languages, okay? Everything still goes back through assembly because assembly is ultimately how this communicates. But this is much like a language. If this was English, English communicates with, say, Latin. It goes with some languages from, I don't know, Indo-European languages, early ones, that communicates with the basic structure of language for man that ultimately communicates with human body. Terrible analogy, but it's kind of how it is. All of this goes through a path to ultimately physically control the way that the processors open gates, close gates, handle memory. And that's an important piece to how programming itself works and why programming is the way it is. So, yeah, it is kind of an anomaly. Nobody expected Python to be as successful as it was, but even people who have coded in C++ their whole lives enjoy how simple Python is. Simplicity in a coding language means it's easier to check and make sure it's operational. It takes away a lot of the, well, did I put my periods in correctly? Where you have a lot of lines of code in C++, it takes very, very few lines in Python. You can execute a nice code in 5 lines in Python. And that may represent 50 lines in C++, which may represent 250 lines in C, which may represent something like 3 to 8,000 lines of code in assembly. But it's only 5 lines in Python. And that's part of why it's so slow, is it takes 8,000 lines to do 5 lines in Python. Okay, but this is something that is generally, in today's world, a lot of people will have created their programs such that they can code applets for it in Python and have it go to C++. Even when Python was first created, maximum processor speeds about 1 gigahertz. Today's processors, you can get much faster than that. 2.5 gigahertz is pretty common in a lot of computers. At the time, though, I mean, you're looking at 500 megahertz processors, 200 megahertz processors, things that were an order of magnitude slower than what we have today. And that was just when Python was created. When Python was created, nobody expected it to be that great, but the issue that we have in today's world is our computers are so fast, they can process information so quickly, that programming in C++ is fairly seamless. Even though this is a fairly high-level language, it can run real time, and it can run real time very, very efficiently. Even though it's so far removed from the actual physical hardware. Python struggles to run real time for a lot of applications, but it's still very fast. Most people don't need a Python program to operate instantaneously. Even though a lot of the machine learning algorithms are written for Python, there's also a lot of them written for C++ if you need more real-time applications. But still, if you don't need a calculation once every 100th of a second, if you can handle it being slower, Python's a great language. A lot of what we've done for our program has not required 100th of a second level control on timing. Now that said, when you get into using microchips and microprocessors and microcontrollers, you may need 100th of a second level control. You may be something where you have to raise a flag if something is red, if the sensor reaches a value that is too high. It has to be able to react within 100th of a second, because maybe 50 milliseconds later, you could have explosion if it doesn't counteract something, if it doesn't process that and immediately react to it. Similarly, if you're creating a microphone, your microphone has to be able to read frequencies that go a lot higher than 100th of a second. You're not going to program a microphone, the actual physical hardware for a microphone, you're not going to program that in Python. You need it to be cheap and you need it to be efficient. This uses a lot of energy. Because there's so many different lines of code associated with programming in Python, it is not very energy efficient. Programming on your Raspberry Pi, as powerful as your Pi is, it takes a lot of energy that it shouldn't. To run that same code just in the assembly language, skipping all of the redundancies that would be needed in order to go all the way up this line. If you were to write the same code in assembly, maybe you use 2,000 lines of code less, it's going to require a substantially lower amount of actual power to do that processing. All of you asked about whether or not you could use an Arduino for your IoT device. An IoT device usually is coded in assembly language for this reason. It significantly reduces the amount of power that's consumed. It may be able to operate off of 0.15 watts of power, whereas an Arduino requires about, just for an Arduino to be on requires about 0.1, 0.5 watts of power just to be on. In addition to whatever coding is required on that. So, yeah, if you can just program directly in assembly language, it is a lot less energy intensive. And that's why, those devices are built that way. Now, again, a lot of people don't like coding here. A lot of applications have been put in assembly and they're posted online. You can find assembly code that does just about anything. If you ever needed to code in assembly, they actually suggest you go online and look for assembly code rather than trying to write it yourself. You can if you want, and you can learn assembly, but it's just a lot easier to find somebody else's code. But that is the process. If you needed to build a sensor using a microchip, you would have to program it in assembly likely, unless it doesn't matter about how much energy is consumed. Which in an IoT device, it does matter how much energy is consumed because the information has to be very infrequent, but very low power systems, because oftentimes these are installed remotely. So for an IoT system, you're not going to be programming it in Python. You're not going to be programming it in Arduino language, which is also, I believe, was also coded in C++. You're going to be coding it in assembly because that's what matters most. All right, any questions on that? Okay, I did not give you a quiz this week. I will not give you a quiz this week. I'm not going to give you a quiz for next week either. Just because, I could quiz you over this, but I feel like this is more for your information rather than stuff that I feel like I should quiz you over. So I'll give you a reading assignment for next week. I will not give you a quiz. On Wednesday, we're going to be taking stuff apart. And then on Friday, we're going to be looking at robots. So, all right. I'll see you all on Wednesday. Hopefully all